In these problems, we are evaluating some expressions that use this sigma notation or summation notation. And if you haven't used this before, it can look a little confusing, but it's not that tough really. What this is saying is whatever comes after here in the parentheses, we're going to do it this many times. We're going to start with 1 and go up to 5. So in this case, we're doing it 5 times. And this variable I is going to increase each time. So we'll evaluate this with 1. I is 1, and then we'll kick it up 1, so I would equal 2. We'll evaluate that again. I would equal 3, all the way up to 5, and then we sum everything. We add it all together. So there's a little bit of work involved, but there's really nothing here that should be too difficult. So in this, I'm going to have to evaluate this expression 5 times, once where I equals 1, and then again where I equals 2, where I equals 3, 4, and 5. So I'm just going to go ahead and write out this expression for each of those situations. So where I equals 1, 1 plus 1 would be 2. That would be squared. And then plus, well, 1 minus 1 would be 0. That's not too hard. And then, well, I is going to go up 1 every time. So we're going to have 3 squared, and 4 squared, and 5 squared, and 6 squared. And here, well, this was 0. Now it's going to be 1 cubed, and then 2 cubed, and then 3 cubed, and 4 cubed. So let's figure out what all of these are. Let's see, that equals 4. This is 10. This is 24. And that's 52. And this is 100. So these are the results of each of our iterations. And now we have to add them together because that's what the summation notation is telling us to do. And that should be 190. You might want to check my math on there. But that's that expression evaluated with summation notation. Let's try one more. Now this one looks like it would be a much bigger pain. We have I equals 1 all the way up to 100. So there are going to be 100 things we have to figure out and then add together. And our expression is I plus 1 over 10,000. Well, how are we going to do this without it taking all day long? Well, let's think about this for a second. The very first iteration here, where I equals 1, you have 1 plus 1, that's 2 over 10,000. And then when we get to our last one, it will be 100 plus 1, so 101 over 10,000. So I want you to think about those as a pair, and then let's go up 1 and down 1 from the top to make another pair. So the next one up would be 3, where I equals 2 would be 3 over 10,000. And then the next one down from that would be 100 over 10,000. And you could keep listing out the pairs like this, and what you'd find is that each one, this is 2 plus 101 over 10,000, they are going to add up to 103 over 10,000. So does this one. And the next one would be 4 and 99. It would still be 103 over 10,000. So what you really have is 50, because we have 100 items, 50 pairs that all add up to 103 over 10,000. Now that's a lot easier to deal with, because if I have 50 pairs of 103, I can just take 50 times 103, and that equals 5,150, and then put that over 10,000. And we'll have to do a little bit of simplifying here. Let's see, we can definitely divide by 10. And then if we divide that by 5, we're going to get 103 over 200. And that is our answer. So that's a little introduction to summation notation. My name is Larry. I'm a teacher at EdVisions off campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethisSchool.org. Thanks.